Hello and welcome back to our advanced level video lectures. And today, in this unit, we will learn about more advanced material design. So the things that you have done so far with the materials in UDK is that we use texture coordinates to set up the panning and the tiling of the textures. We set up time varying materials, and those were the most advanced things that we learned so far that you can do with material editors and the material factory in Unreal. And the basic stuff like applying different colors to your material. We learn a little bit about diffuse, specular, and emissive components of your materials and what textures are. In this learning unit, you learn a bit more about advanced things that you can do with material. We start with setting up a material change by distance. So as the distances of the objects from the viewer change, the material color will change, and then we incorporate some sort of timing to that as well and make your materials come to life, so to speak. And then we learn a bit about more advanced materials, creating your custom lightings. We will learn how you can create translucent materials like water surfaces and manipulate the material so that it will look like it's water. Basically, the refraction properties of your materials, reflection properties of your materials, and the panning and tiling of ripples on the surface of your material. We would study those. So, but for now, let's start with a material that changes its color by distance. And we will learn to apply custom lighting to your materials. So if you remember from the last learning unit, when you create materials, you would have to put lights in your environment so that the light interaction with your environment materials would make them look the way you intended them to look. We can actually use custom lighting and just apply your material looks into your emissive component of your material, and this way your materials would shine and you will not need any specific kind of light for them to show up. So we'll start by opening your content browser, right click somewhere and create a new material, and let's put this material into a package and I call it my package materials. I'll create a material grouping and I call this matte changing color. So this way I created the material in a custom package, and here's how my material looks like. Now if you click on your material and from the material properties, if you change the lighting from MLM or material lighting mode to unlit, your material will basically will be an unlit material, meaning that it doesn't require any light to show, and it would only have an emissive color. And so you can make it emit this color. And here's just a basic and save this material, and from the material editor, if you select the material and then apply it, you see that everything is dark, and it will be dark under lit condition and unlit condition of your viewport. Now if you create a color constant, a vector 3 constant, and give it just a color, let's say that I will give it this kind of reddish color look, and then apply this into your emissive channel and save, you will see that your material would basically emit a reddish color. Okay, but you won't see much of any pattern on your material, and that's because you don't have a texture. Now to make your material essentially have a texture so that you could see texture patterns on your material, you could bring a texture sample, and I'll go ahead and load these texture materials and click on textures, and I will bring the wall stone texture as a sample here and create a texture sample, and then multiply this texture sample with your material color. and then apply this to the emissive component of your material. And when you save your material, you will see that now your material shines even on the unlit mode. So the material doesn't look different under lit or unlit mode. However, it's pretty dark. So to make it look a bit brighter, let's just drag these expressions to the left a little bit, and then multiply this entire material texture that you created to 5 and save your material. So now you see that your material is basically shining. We can make the material shine even more by increasing this multiplier. So if you make it 50, now your material really shines out. And if you play your level, you see that you don't even need to build your lighting because your material is unlit. So it basically looks like it's emitting light because its emissive channel has expressions in it. Okay. Now you see that the textures look pretty small. You can add a texture coordinate by right-clicking and going to coordinates and bringing a new texture coordinate and applying that texture coordinate to the texture of your material. And if you click on the texture coordinate, you see that U tiling and V tilings are 1. If you make them more, say for example 2 textures, coordinate texture tilings, or 4 texture tilings, you see that your material texture becomes finer and finer. And by making them smaller, say by 25% along an X and Y direction, your material texture becomes stretched or scaled out. So play with these values and see which values suit your interest best. And when you created these materials, as you see here, you will have your tiling of your material set up and the texture applied to your material. However, if you look at this material right now, you will notice that the color of this material is basically the same regardless of how far the objects are from the camera, which is the viewer here. Now to make this room a little bit more interesting to walk in, you may want to have your materials kind of fade towards a darker color as the wall distances from the viewer become larger. To apply this, we would need to use 2 different color values, and I'm dragging these colors to the left, and then we interpolate between the 2 values. So what we will have here is that we will have 2 colors. So let's create another color. Let's make this second color a black color. Okay, and then we would interpolate between these 2 colors based on the distance of each pixel from the viewer. The components that we need here is a pixel distance or a pixel depth and a linear interpolation. Linear interpolation is the LREP function, which is basically from the utilities, and it's called linear interpolate. If you bring the 2 linear interpolate expression here and add your material A and material B to the A and B input of your, or the color A and color B to the A and B input of your linear interpolation, this expression, according to what value of all alpha is between 0 and 1, would choose a combination of the 2 value colors A and B. So if alpha is 1, then the value would be 100% A and 0% B. If the alpha is 0, it will be 0% A and 100% B. And if alpha is something between 0 and 1, it will be some combination of A and B. And then you can apply the output of linear interpolate to your input of your material. Now, what we want this combination of the two colors to be based on the depth of pixels or the depth of objects. So right-click, and then from the depth category, bring a pixel depth. So the pixel depth is an expression that for each pixel in the scene that you see here, will have a value, and that value will be in unreal units. So if the pixels are closer to the camera, their values is less, and if they're farther from the camera, their values is going to be more. Now if you apply this pixel depth and apply the output of linear interpolate to your material, your objects or your material will look very shiny because the pixel depth is large at this point. What we want to do is that we want to divide this pixel depth by some constant number. So the materials that will be farther from a constant number will be more or 100% of the dark color, and the materials that are closer than that distance color to be more of the original color. So we will divide the pixel depth by the base distance. Let's say here we'll make it like 600 units. And when we divide these two, if the materials are farther from 600, then the values will be greater than 1, or basically it will be 1. If they're closer than 600, then the value would be something between 0 and 1, and then we apply that to your material. And so if you apply your material, you'll see that the darker, the farther areas will become pretty dark than the objects that are closer than 600. And if you move your material out, you see that your materials will become brighter as they get closer to the camera, and as you go farther from the camera, they become darker and darker. And when they are much farther, they will be essentially completely dark. Okay, so let's play the level, and here's how you see that shade, that dark shade that you see there is based on the distance from the camera. And so as the materials go farther from the camera, they become darker and darker. Okay, as you may notice here, because of the multiplication factors, your colors are a little bit saturated, and to desaturate your colors, we can use a desaturation component. If you right click in the utility, you'll find the new desaturation component, and click on the desaturation component and control drag it down. Get the input of your texture to your desaturate value, and then create a constant value and make it 1, basically 100% desaturation, and then apply the output to the multiply texture sample. And so you see that your material look turned a little bit different. Let me just replace that. If you use the texture itself, the texture and color are saturated a little bit, and then the saturation, as you see here, desaturates your textures. And if you apply your material will look a little bit better with the desaturation component. Now let's play the level one more time. Now here I am just moving in the level, and as you see, the materials that are farther from the camera look darker. But if you look at the face, or basically if you look straight on, plain, like a wall, it would look pretty bright. Let me just increase the depth distance for the material fade to 1000. Okay, so I would have a lot more room basically to see. Let's increase this to 1500. Okay, as you see, as I'm increasing that depth, the darkness starts from much farther. There's a nice component here which is called the Fresnel expression, and the Fresnel expression basically multiplies the color of your materials. If you multiply it to the angle that you have, the angle of your view from each pixel. And the way that it applies is that if you're looking at surface dead on, the material that you will see becomes darker and darker. and if you just look the surface on a tangent view, then the surface will become brighter and brighter. So this is the Fresnel component. The Fresnel expression is under the vector operations. So if you bring a Fresnel expression here, you will notice that it has an input, which is basically the normal to the surface, and then it has an output. And so the Fresnel takes as input the normal of the surface and calculates as the output the sign between the viewer vector and the normal vector. So if the viewer vector and normal vector are at 0 degrees, basically they are looking dead on at each other, the Fresnel value will be 0. That would be dark. And if the viewer vector is perpendicular to the normal vector, the Fresnel value will be 100%, which will be 1. So if we multiply this into the output of our material, and then replace the emissive with multiplied Fresnel, you see that when we're looking dead on at the surface of the sphere, they become dark. And as pixels go around the sphere, the angle of view becomes larger with respect to the angle of the normal, and so the Fresnel becomes brighter and brighter, and so you see more colors. And when you apply this scene, now the pixels that you will be looking at dead on becomes darker, like this. And so it gives you more of a spooky view in your scene. Now this Fresnel is not just to use this dark surface, basically, as you look at it dead on. You can use the normal of a material and apply it as the input of your Fresnel to give the three-dimensional look. And if you look at here, your material looks like paint on the wall. It doesn't have that three-dimensional depth. So if we go and open the content browser and bring the texture coordinate of the normal to the content and use it as the input to the normal and get the texture coordinates, because we have changed the tiling, and use the texture coordinates on the texture coordinate input of the texture sample for the normals, and then apply it. Let me just get closer to a surface here so you would see the difference. Look at the surface. Right now I haven't applied the texture normals to the Fresnel, but when I apply it, you see that the material looks a lot more three-dimensional. And if I play this level, you will see the difference that it makes. See, now your texture looks a lot more three-dimensional as opposed to what you had before. Look at the areas on the surface of the stones here, or the bricks. Okay? Now let me drag the materials out and let me reorder everything in groups. So I have this depth division here that linearly interpolates between the two colors, the orange color and the dark color here, and that is going to be applied, the linear interpolation is going to be applied to this multiply to the texture, and then I use this Fresnel expression to give three-dimensional look to my material. So let's rearrange these, and this will be my texture coordinate. And I will have my depth interpolation of the material on top here. Okay. So far, so good. Now, one other thing that I want to apply to this material is a basically time varying texture on the surface of this material, or what we call an animated texture. For making my texture animated, what I can do is that I can bring a texture that would dictate how colors that I have will be changing over time. And then I can use panners and rotators to apply in the texture coordinate. So this way I can move the tilings of my textures around. So to do that, I will bring a texture sample based on a black and white, or basically a grayscale flame-based texture. So click on the flame-based texture and then hold down the T key, and that brings your texture sample and fills it with the two-dimensional texture bitmap that you wanted. And then right click, and then from the texture coordinates bring in a panner. And as you see here, the panner has two inputs: a coordinate that gets input of texture coordinates for UV tiling and the time. For now we won't change the timing, and we just add the panner, and we make the panner values at speed along X, for example, something like 15, and along Y, let's make it 0.23. And then right click from the texture coordinates, bring the texture coordinate, and make the U and V tilings 0.3 and 0.4, for example, and apply to the texture coordinates of the panner. So what happens here, the texture coordinates define the tiling of the texture, which is this texture sample, and the panner moves the texture 15% and 23% along X and Y directions. Okay. Now Control Alt and left drag to select all these three samples, and press Control W to duplicate it, and one more W to duplicate it one more time. Okay, and then go to the texture coordinates here and change these texture coordinates, say to 2.5 and 1.8, and then for the second panner I'll make it -25 and -45. For the third coordinates I'll make it 1.2 and 2.8, and then for the panner speed I'll make it -0.3 and -0.2. And then bring two multipliers and multiply the first two coordinates or texture samples, and then multiply the resulting texture sample to the third texture sample. And here you see that your texture sample, if you turn on the automatic review, you see that these will change. And then to make it a bit brighter, I'll bring a constant number, make it say 5, and then multiply these values, and then multiply the entire result that you've got so far to the output of the texture that you have created so far. So this way, that moving texture will be multiplied to the static texture that you have and applied on the emissive power. And here, when you apply your texture, you will see that now you will have an animated texture on the surface here. And of course, you can play with the values of your panners and UV tilings to basically control the tilings of your texture and the speed and the tilings of your animation on the surface of your texture. To make this even more interesting, if you look at the animation, basically I have a flame-based texture that I'm creating three different movements and texture scales, and multiplying them, and that would dictate the animation or the movement of the flame on the surface of my texture. I have a static texture with its normal, which is my brick texture, and I'm applying that with a distance-based interpolation, and that will make the texture go darker as you go farther from the camera. But the color, the base color of my texture is kind of reddish here, and it doesn't change. Now, by replacing this colored texture here, this orangish colored texture here, in the middle of the screen here, with a linear interpolated texture between two different colors, then I will be able to change by time the color of this material as well. So to do that, let's bring two base colors. So I'll bring a base color of dark orange, kind of like that, and then I bring another color and make this color bright green, and then use a linear interpolation to interpolate between these two colors. Now, if you remember the first time that I did that, the interpolation alpha was based on space. Now I can make it based on time, and for that I bring a time component. So right click from the utility, bring a time component, and then bring a sign component from the map. And since this sign component ranges between -1 and 1, and I want it to be between 0 and 1, I can multiply my sign with 0.5. So it would range between -0.5 and 0.5, and then add this 0.5 to it, and now your sign ranges between 0 and 1. So the output of the sign value here now ranges between 0 and 1. And if I use this addition as the interpolation, now you see that the color ranges between from orange to green based on the sign component. And if you apply this value instead of the orange value that you had, now you see that your texture is animated. It changes between green and orange as time goes by, and it has a flame base on top of it that changes based on the panner values. Now, to make your change between the two colors go slower, you can multiply your time with a value smaller than 1 and use it as the input of your sign. So multiply the time by 0.05, and this way you see that the change from green to orange becomes a lot slower, as you see here. Now it's going to orange and then going back to green. If you increase this time multiplier, you will see the speed of the color change becomes faster. If you decrease this value, you see that the speed of the color change becomes smaller. And then let's apply and let's play our level. As you see here, color is green, and as the distance of the objects from the camera become more, the colors become darker. And of course, the speed that I have set up here with the 0.01 multiplier is pretty slow. Let's increase the 0.01 multiplier to 0.2 and then play the level. Now it should be much faster. So the color changes between green and orange based on time, and texture flame moves on the surface, as you see here. Okay, now I'm going to save my packages here, and then we move on to the next material, which is a wax material.